To understand the long division of polynomials, first we will try a long division of regular whole numbers. So I want to find the quotient and remainder of the division 1287 divided by 41. I set up my division table and I am thinking how many times does 41 fit in 128. I don't know the multiplication facts of 41, so actually what I am thinking is how many times does the 40 fit into the 120. And 40 fits into 123 times, so I'm going to assume that 41 fits in 128 3 times. Then I will multiply 3 times 41, which is 123, and I will subtract the 123 from the 128. So minus 123, the remainder is 5, and I will drop the 7, and then I'm gonna think how many times does 41 fit in 57. Again, I'm looking at how many times 4 fits in 5. 4 fits in 5 once. I'm gonna write the 1 over there. I'm gonna multiply 1 times 41. It's gonna give me 41. I will subtract the 41 from the 57. I will get 16, and that will be the remainder. The quotient is 31. To check if I did the division correctly, I will multiply 41 times 31. Let's do that somewhere. 41 times 31. 1 times 1 is 1, 1 times 4 is 4, 3 times 1 is 3, 3 times 4 is 20. It is 1271, and then I will add the remainder, and the answer should be the original dividend. That is 1287. So I checked my division. Now I'm going to do a similar process with polynomials. I want to divide x to the third minus 11x squared plus 36x minus 35 by x minus 4. I'm going to set up my division table so that the dividend is under the bracket and the divisor is outside. And I'm going to check how many times the leading term of the divisor, which is x, fits in the leading term of the dividend, which is x to the third. X to the third divided by x is x squared, and I'm going to write that in the quotient area, and then I will multiply x squared by the divisor, x minus 4, and that is x to the third minus 4x squared. Now I have to subtract. Subtraction is addition of the opposite, so I will switch the signs of the product, negative x squared, negative x to the third plus 4x squared, and now I will add. The leading terms will add up to 0. I will end up with negative 7x squared plus 36x minus 35. I will repeat the process. I'm going to check how many times the leading term of the divisor fits into the leading term of the partial dividend. Negative 7x squared divided by x is negative 7x, and I will write that in the quotient area, and then I will multiply the negative 7x with x minus 4. This is negative 7x squared plus 28x, and I have to subtract. I subtract by switching the signs and adding the opposite. So I'm gonna add positive 7x squared minus 28x. The leading terms will add up to 0. I will end up with 8x minus 35. Repeat one more time. How many times does the leading term of the divisor, which is x, fit into the leading term of the partial dividend? 8x divided by x is 8. I will write that in the quotient area. I will multiply the 8 by the divisor. This is 8x minus 32, and I will subtract. I will subtract by switching the signs and adding the opposite. Negative 8x plus 32. Negative 3 is my remainder, and the quotient is x squared minus 7x plus 8. Now, if I want to check my division, I will multiply the quotient x squared minus 7x plus 8 times the divisor x minus 4, and I will add the remainder. And if I have done it correctly, I should end up with the dividend. So let's distribute. Let's distribute the x first. X to the third minus 7x squared plus 8x. Let's distribute the negative 4. Negative 4x squared plus 28x minus 32. And let's add the remainder. This is equal to x to the third minus 11x squared plus 36x minus 35. And sure enough, this is the same with the dividend I started with. So my division is correct.